Module 3 Design of Compression Member. The topic involved in this video are 1. Possible failure modes. 2. Behavior of compression members. Possible failure modes. The possible failure modes of an axially loaded column are: first, local buckling; second, squashing; third, overall flexural buckling; fourth, torsional and flexural torsional buckling. In that, first one is local buckling. It means the failure occurs by buckling of one or more individual plates element. Example for that: flange or web, with no overall deflection in the direction normal to the applied load. The failure modes may be prevented by selecting suitable width to thickness ratio of component plates. Alternatively, when slender plates are used, the design strength may be reduced. These are the examples for local buckling. Second one is squashing. It means when the length is relatively small and its component plate elements are prevented local buckling, then the column will be able to attain its full strength or squash load. These are the example for squashing. Third one is overall flexural buckling. This mode of failure normally controls the design of most compression members. In this mode, failure of the member occurs by excessive deflection in the plane of the weaker principal axis. An increase in the length of the column results in column resisting progressive less loads. This is the example of flexural buckling. Fourth one is torsional and flexural torsional buckling. Torsional buckling failure occurs by twisting about the shear center in the longitudinal axis. A combination of flexure and twisting called flexural torsional buckling is also possible. Torsional buckling is a possible mode of failure for point symmetric section. Flexural torsional buckling must be checked for open section that are singly symmetric and for section that have no symmetric. These are the images of flexural torsional buckling. The next topic is behavior of compressional members. The compression members are sometimes classified as: first one, long compression members; second, short compression members; third, intermediate length compression members. In that, the first one is long compression members. For these compression members, Euler's formula predicts the strength of long compression members very well, where the axial buckling stress remains below proportional limit. Such compression members will buckle elastically. These are the formulas related to long compression members. Second one is short compression members. For very short compression member, the failure stress will equal to the yield stress and no buckling will occur. Consider an axially compressed member of short length which is initially straight and made of material having the ideal rigid plastic stress-strain relationship as shown in the figure. Since at low values of external load P, there will be no visible deformation, neither lateral nor axial. P is applied at the centroid of the section apart from possible localized effects. At the end of the members, all parts of the members will experience the same value of compressive stress. Fc is equal to P by A. Large deformation possible on Fc reaches the yield stress Fy. At this stage, members deforms axially. The third one is intermediate length compression members. For immediate length compression members, some fibers would have yielded and some fibers will still the elastic. These compression members will fail both by yielding and buckling, and their behavior is said to be inelastic. For the Euler formula can applicable to these compression members. Thank you for watching.